All right, we have to work on an important topic, distance and midpoint. You want to have a good calculator out. You want to make sure it's in working order, ready to go. And I'm going to, after this lesson, I'm hoping that you will be able to calculate the distance between 2 points and find the midpoint of a segment. So there's a few things that we haven't touched on that we're going to see today. We actually did look at this and do something with this in our ISN already, which was just finding the distance between some points on a number line. And I had said that the number to the right on the number line is always the largest. And this one on the left would always be the smaller of the two. So I can say smallest. So if you want to avoid all this absolute value stuff, all you got to do is do the max, which would be the largest number minus the min. Max minus min. And I brought that up the other day. And you'll find the distance. So it's subtracting to find distance is what you need to do. Doing a midpoint is just like averaging the locations between A and C. So if you wanted to find B, the midpoint, that's going to equal that, right? That's what those slashes mean. And what you do is you take the coordinates of A and B, you take A plus C, and you divide by 2, and that will equal your B value in that case. Okay, so you're averaging the coordinates. So let's do some examples that are concrete. If I want to use this number line to find the distance from A to B, B would be the maximum point, and A would be at the minimum because it's on the left. So I'm going to do B minus A, and if I substitute in 2 for the B, minus, don't forget it's subtract always, put in -4 for the A, then we can type, and I want to make sure everyone knows where that negative key is on their calculators. So I'm going to type, now I forgot my numbers, 2 minus -4, 2 minus. Now, if you aren't real familiar with these calculators, the negative sign is way down here to the left of enter. You have to use that button for a negative. 4. No, 2 minus -4, and you should realize that you're going to get to +4 from what you learned about integers. However, your calculator can help you out. It is 6. Okay, so the distance from A to B is 6. Okay, use the number line to find the midpoint of AB. You might have been saying to yourself, why didn't you just count from -4 to 2? Well, you can if you have a number line. But do you always have everything drawn out a number line? No. You still need to be able to do max minus min. But you could have gone 1, 2, 3, 4, 5, 6. Now, it looks to me like, what's in the middle, do you think? Looks like it's going to be right there, right? -1. So let's see. Formula, so let's say you didn't, again, have that luxury of looking at the number line. The rule is to take A plus B and divide by 2. So I'm just going to substitute in -4 plus B value of 2. And then I want to show you something, and I need you to pay attention to what I'm typing. If you type -4 plus 2, and then you hit divide by 2, does this make sense? I got -3. Now, I had a student that you may know named Brandon Burke. And he is in my 4th period, my study group. They're awesome, though. I mean, I love my classes. He came up with the perfect explanation of why this didn't work, and I was very impressed. Does anybody have a good reason to tell me? Because we already decided it should be like -1, right? I was just curious if anybody else had anything they might think of. Okay, now I got lots of hands going up, so I still don't know. I have so many students. Okay, so I know I'm on the wrong page here. Carolyn, I saw your hand up, and I know Nathan's got his, and who else had their hand up too? Also, that's Ken, right? Okay. you went first. So I'm going to go Carolyn. I think you had your hand up first. Oh my gosh, she used those words too. PEMDAS. How many of you remember PEMDAS? You heard that? Awesome. Okay, please excuse my dear Aunt Sally. Okay. And that was parentheses, exponents, multiply, divide, left to right, add, subtract, left to right. It's order of operations. Very good. Nathan, what do you have to say? Awesome. Another great thing. Okay, you need parentheses. That would solve that problem. Because what's the calculator doing? Yeah, it's dividing before it added. Okay, so that I want to show you because I'm telling you right now, there are going to be plenty of people that try to type this and they're going to do this and they're just going to write the answer. They're not going to think about it and they're going to get it wrong. Okay, so that's why I explain this so that you don't do it. Hopefully you heard me. -4 plus 2. This was Nathan's suggestion. Did you have anything else to add, Kenneth? Or Ken? Okay, thank you. Ken or Ken? Kenny. I should write that down. Okay, so now if you type it like that, oops, now we got the answer that we expected. What I usually do, or what I think works best for most kids, is there's a lot of more buttons to press to type in the parentheses. It might be faster if you just do -4 plus 2 and then hit enter and then hit divided by 2. And there's our -1. So we see how if you type it in wrong, the calculator is only as good as what you type. Okay. All right. So -1 is our answer, and I really beat that one to death. But why? Okay. And then it makes sense because you can see it also. All right. So let's use this number line to find each measure, and I am going to go faster now. Okay. B to D. If I go find the coordinates of B, which are at -7, and the coordinates of D, which is at -1, it says this means distance, the distance from B to D. Since D is on the right-hand side on the number line, I'm going to start with that coordinate of -1. Distance is subtract. Okay, and a moment ago we were adding. We are now subtracting because we're doing distance. -1 minus -7. And so if you're really uncomfortable with the integers, just type it on the calculator. Well, I'm going to go ahead and do it out the long way. Oh, if I didn't actually already hit that button. -1 plus 7, and this should be +6. So if you can do it without a calculator, more power to you. All right, so from B to D, you could go and check if that made sense. 1, 2, 3, 4, 5, 6. And yes, that is the correct solution. If you don't have a number line, you can't do that. B to G, G is at -1, G is at 8. So since G is on the right-hand side, I'm going to start with the 8. I'm going to subtract D from it, which is at -1. 8 minus -1 becomes 8 plus 1, which is 9. So the distance from D to G should be 9 spaces, and you could count it off to double check. A is at -9. F is at 3. So the distance, I'm going to use the most right point, which is the 3, where F is. 3 minus -9 will give us the distance. That's 3 plus 9, so our distance is 12. Okay? So again, distance, you're going to subtract. All right? Do max minus min. If you're going to do midpoints, we are going to add and divide by 2. All right, so we find the coordinates of segment A and B. A is at -9, B is at -7. Okay, personally, I realize you probably just write the answer down because what's right between -9 and -7? -8. Okay, now, how would you have gotten it if you used the formula? Say you didn't have the picture. You take the -9 plus the -7 and divide by 2. So you add these first. That's -16. You divide by 2 and you get your -8. Okay, C to D. C is at -4. D is at -1. So I'm going to add -4 and -1. I'm going to get -5, and then I have to cut that in half. So I'm going to get a decimal of negative 2.5. And last one, B to D. B and D have coordinates of negative 7 and negative 1. Add negative 7 and negative 1. That gives you negative 8. Divide that by 2. And we get negative 4. Did I go too fast for anyone? Yes? Okay. So I'll wait a moment. If you have a question, do you have a question about any of these? Oh, I'll just need to slow down a little bit, I think. Thank you. Thank you. What I thought. Okay. All right, now comes the harder part. All right, Pythagorean theorem and mean distance. Let's see, I'm going to relate. 1 second. Reviewing the Pythagorean theorem and the mean. Mean is just average. Okay. Pythagorean theorem, this is what we had trouble with. Now, I made a different problem right here so I could explain again today the difference between the first problem and the second problem. I put a 20 here, right? I put a 12 there, and I put an X here. All right, now, these are different. What we need to do is I'm going to take my highlighter, as I suggested, and I got to get straight on where the legs are. The legs make the right angle. So in this particular one, the legs are the 7 and the 24. The hypotenuse is always the long side. Actually, I don't want to make it blue. I'll tell you why. Because I'm going to use blue to mean something else in a couple of minutes. So I'm going to make it green. All right, now, the Pythagorean theorem says that leg squared plus leg squared equals the hypotenuse squared. This is a leg, this is a leg, and this is the hypotenuse. So, in this case, we're just ready to go. The legs are given, we're trying to find the hypotenuse. So our first step would be to write 7 squared plus 24 squared equals x squared. Next, we would grab our calculators, because not many of you are going to know these by heart. 7 squared plus 24 squared. On our calculators, what we would type, that would give us 625. Okay, does anybody need help finding the squared button, the button that does squaring? Right there. Right here. Okay, I got 625. So right now where we are is 625 equals x squared. Now, this is the one that most of you did well on if you remembered anything. And then some people knew how to do this kind, where they would find the hypotenuse. They did this part all right, and they would get this particular question right on that quiz. Because they would have taken the square root of both sides. That would have given them 25 equals x. And again, how you type the square root of 625 is you hit second button right here. You hit the x squared button right there. You get the radical sign, which is square root. You put in the 625 and you hit enter. All right, so there's your answer, 25. Now, people got this one right, and then those, some about 50% of the people who knew how to do this type, did this type wrong. Okay, so what I had was 2 of each kind on the quiz. So let's discuss the difference between them. And I know you don't have all these. I've made a whole new problem because this stuff didn't print. Wasn't taking. I couldn't get it to print, so I made a different problem. So what you've got is the hypotenuse here, which has got a 20 on it. So the problem is not the same as the problem on the left, on number 8. The legs, Kenny, would you mind closing the door for me? Thank you. Are here and here. This is where the right angle is. Yours is facing the way I have this drawn, right? It basically matches up except for the numbers I had to change, right? Okay, so what do we got? Well, and I understand you probably know if you didn't understand the Pythagorean theorem well. This is a leg, or if you didn't remember it. This is a leg. And that is the hypotenuse, the long slanty side. Okay, so here's what we got to do. We still are supposed to follow the formula. Leg squared plus leg squared. One of our legs is x. So it goes x squared plus 12 squared equals 20 squared. Doesn't look like this, does it? Because I had something to fill in for the hypotenuse on this one. This one was different. X was on that green side. This one, the X is on a leg. So we're going to figure out 12 squared. 12 times 12 is 144. 20 times 20 is 400. We're going to subtract if we have to find a leg. Okay, and we will get x squared is 256. Now, this answer doesn't match my problem, so I'm writing over it. The next step is to take the square root of both sides. So you find out what's the square root of 256, and it is 16. I heard some of you say it already. Now think about it. Doesn't that green thing have to be the longest piece? We got 16. That'll make sense. 12, 16, and then the biggest one is 20. It's gotta always be that way. Okay? These legs must always be smaller than that, whatever it happens to be. Now, I bet some of you could do the problems now. You probably go back and maybe do it, and some of us are not there yet. Now, to find the mean between, it's just averaging, so we're going to go pretty quick here, please. To find the mean between 30 and 34, you will add them and divide by 2. 30 plus 34 is 64, and then you're going to want to divide that by 2. And that, of course, is going to be 32. Okay, try the next one, please. Now, I had students ask me, Ms. Heimer, do I actually have to write all this work out for a problem like that? And I said, no, but because I know a lot of you just do it on the calculator or something. I'm teaching right now, and these are notes. So you're showing yourself where you got your answer from. Often that's a really good thing to do anyway, because I can give partial credit to a student who maybe showed something and just did like a boo-boo in between. Like I almost did once when I went 15 plus 27 and I wrote 44. Why, I don't know. It just came out. 15 plus 27 is not 44, it's 42. But what if a student gave me the answer of 22? And then somebody else gave me 21. Well, if you got to 21, you're all good. You did it right. But if somebody showed me this, I wouldn't mark off the whole thing because they made an addition error. Does that make sense? That's what I'm talking about, showing work. Thank you. Okay. All right, moving on. Now this is the hard part. Pythagorean theorem. Nathan, I have a note for, not that Nathan. I know. Nathan, I have a note for you. If you want to grab it, it'd be great. I'm recording. Thank you. Using square roots to find the distance and then the midpoint formula. This formula, I get it. It looks like crazy hard, right? It's big. I want to break it down and make it look less ominous, okay? So I'm going to use highlighters, and I'm going to use pink for X and blue for the boys, the Y's. Okay, and I want to get this formula simplified for you. X just stands for when you're finding X. Remember how we just subtracted numbers to find the distance between them? That's what that is. You're finding the distance between the X's. And the X's would be the horizontal ones. Okay, the horizontal distance. Y's are going up and down because there's your Y-axis. That's going this way. And the Y values are the blue ones here. You're just finding the vertical distance. Okay. Notice that that's our little right triangle. So a squared plus b squared equals squared. The Pythagorean theorem could be applied to this. That would be like the C. This would be like your A and your B. So we can relate this lovely formula to the Pythagorean theorem. This formula that looks so yucky is an application of the Pythagoras' theorem for right triangles. If you were taking a squared plus b squared equals c squared, and you wanted to solve for c, you would need to take the square root of both sides. That's where they're getting this from. You see it? They took the square root of c squared and got c, and then they had to leave this like that. The square root of a squared plus b squared. It's just another way of thinking of your horizontal distance and your vertical distance. Your horizontal was right here, the A part. Your vertical distance was the B part. And what you're trying to find is the C part, that hypotenuse thing. Okay, so again, change in the X's or difference in the X's is right there. Find how far it is from here to here. Find how far it is vertically. That's this part of the formula. So whatever you get for this distance and this distance, you square it, you add it, and then you take the square root. Okay? And then you find the green part, which is what we're trying to find. So now I'm going to break down these next problems again with the colors. So maybe you want me to wait a second here still on this. Okay. Anybody still need it? I know I switch colors very quickly. Okay. Midpoint. Let's talk about the second formula we're going to be working with in a couple of minutes. X's again, but this time you're just doing, remember how we found the midpoint on the number line? All we did was add the coordinates and divide by 2. We're doing the same thing, except we have to do it for the X's and the Y's. Okay? So this is just averaging the X's, averaging the Y's. All right, so jump to the next. Let's do an example. We are going to take this point, these 2 points, excuse me, and we're going to find the distance between them, and we're going to find the midpoint of them, between them. All right, so this is x1, and this is my x2. Each point has an x value, an x component, and a y component. The x component always comes first, and the y component comes second. So this is y1, and this is y2. Oops. All right, now I'm going to find the distance first. I'm going to do the harder formula first. We're going to write it out on the paper, and then I'm going to tell you what to type in the calculator so as to become proficient at this, I'm hoping, if you will listen as to how to type it. I am just going to substitute these little guys into the formula. So these will be the pink guys. All right, the X values are going to be my first things I subtract and my square, and my Y values are going to come second. And so it has to stay in that combination. So if I do Y, I'm going to follow the formula to the T. Honestly, you can subtract in any order and get it right, as long as you do it consistently or correctly. 6, I'm going to start with 6, but I'm going to put a parenthesis, just like the formula says. It says parenthesis x2, that's 6. Minus, says to subtract, x1 is a 9. Parenthesis squared, plus, parenthesis. I'm going to put in my y2. It's a 1. I'm going to write subtract. Then I'm going to see what my y1 is. It is a negative 3. I need to put in the negative 3. And remember that I'm subtracting. So this is what it looks like plugged into the formula. Again, these were my x's. These were my y's. Okay? Next is a calculator time. Okay, so I'm going to type this in the calculator, but I'm not going to put the square root. I gotta be honest, some people would get it right if they did the whole thing at once, but too many people get it wrong when they do it all at once. So I'd like you to do just the stuff underneath here first, and I'm going to do each step separate, okay? So I'm going to go on my calculator, and I'm going to hit parenthesis. They're right here in the middle. 6 minus 9. I'm going to type it just like it looks on my paper, parenthesis, and then I'm going to type the squared button. That's what it should look like. Now, if you know your integer stuff, 6 minus 9 is negative 3, and negative 3 squared is negative 3 times negative 3, so this ought to come out to be 9. If you typed it incorrectly, you should be getting 9 when you hit enter. Okay, that's the part right there. The whole thing gave us 9, so I'll have 9 plus something. Now I'm going to do this part. I'm going to put in a parenthesis. I'm going to do 1 minus, now that's subtract. You got to use this button here. And then I have a negative 3. And I'm going to close the parenthesis, and then I'm going to hit the squared, x squared button. And then I'm going to hit enter. Now, this should come out to be 16. 1 minus negative 3 is 4. 4 to the second power means 4 times 4, which is 16. And it is 16. Did everybody get the 9 and the 16? No, okay, you're not going to tell me yet. I'll probably find out later. Okay, so let's see. We got 9 plus 16. If I add 9 and 16, I get 25. I'm just going to finish this off without my calculator. The square root of 25 means what number times itself is 25. And that'd be 5. Okay, now we're going to do the midpoint. I'm still going to work the same values, x's I'm going to put together, but this time midpoint tells me to add. So I'm going to add my x's. 9 plus 6 divided by 2. And then I'm going to do my y's, negative 3 plus 1 divided by 2. And again, if I want to show that, these were my x values. These were my y values. I add when I do midpoint, and then divide by 2. Okay, so first I'm going to add my x's 9 and 6, and that's going to give me 15. And then hit 15 divided by 2, and you'll get the x part of the midpoint. Which my pen's stuck, so I'm waiting. Okay, 7.5. I add my y's. Negative 3 plus 1 is negative 2. And when I divide that by 2, I get negative 1. Now is when I'd really like to be walking around, but since I'm recording, I'm not going to be able to. I want you to do the next one. I want you to start getting it set up. I'll still go through it. Okay, I'll go ahead and highlight again because we need to all be practicing right now. X1, X2. My Y1 and my Y2. Okay. And now I'm just going to start typing or whatever. Distance is the square root of. Ooh, that's a cool looking pen. 1 minus negative 4 squared plus negative 5 minus 7 quantities squared. Type on the calculator. 1 minus negative 4 is 5. You're going to figure that out. You probably just got 25, I'm hoping. And I'm just going to show it as if you wanted to do it without a calculator, if you're like doing it within your head. Negative 5 minus 7 is negative 12. So I still need a parenthesis around it. Negative 12 squared is 144. Okay, I'm hoping if you type this all that you got the square root of 169. And then when you find out the square root of 169, it is 13. Now I'm going to do the midpoint. I'm just going to add my x's. Negative 4 plus 1 divided by 2. And add the y's. 7 plus negative 5 divided by 2. The negative 4 plus 1 is negative 3. 7 plus negative 5 is 2. If you typed in your calculator negative 3 divided by 2, you're going to get negative 1.5. Decimals are fine. 2 divided by 2 is 1. Okay. Try another one. If you like labeling, if you don't have to label, that's great, but you better be sure you don't need to and that you're getting them all right. Okay. Give it a shot. I try to go ahead of me, please. I'm going slow because I want you to have tried it. I would suggest that you can definitely type, was it 5 minus 2 for the x's? You can do this, and I have no problem with doing all this at once. Or the y parts, 12 minus 6, I think. You can just do all of that at once if you want. If you type it carefully, we should be getting 45. Now, if you take the square root of 45, you might remember something back in, you may remember doing this in Algebra 1, breaking apart a 45 into a perfect square times a non-perfect square, and then simplifying it by doing the square root of the 9, which is 3, and the square root of 5, you'd leave under the 5 because it's not a perfect square. I'm not going to make you do that. We will eventually study this some, but I'm not going to make you have your answers like that. But I think that if you can do it, that you might want to give me 2 answers just to have the practice on this, because you will definitely need to get proficient with that in Algebra 2. So I'll take the decimal though, guys. So if you just hit square root of 45, that's approximately 6 point, I forgot. Okay, and I think, I don't remember, does it say what decimal place to go to? Hundredths? It says tenths, so just like 6.7. Yeah, so notice I would take either of those answers, so don't sweat it if this isn't your thing yet. You don't get it yet, or don't remember it. All right, and then midpoint. This should be pretty quick. We're just going to add 2 and 5 and divide by 2, and 6 plus 12 divided by 2. And we should have 3.5 and 9. How many of you got all that right? I mean, before I even went over that problem? Okay, that's not as many hands as I'd like to see, but it's still a good start. Okay. If you are having problems with deciding what you're doing with this formula, I'll definitely want to help you. And I need to give you your assignment. Or you got it already, don't you? You got the homework? You need to practice. I cannot stress this enough. This is a super, super important concept, right? Throughout the year, we will need distance formula.